In this video, we're continuing on with section 1.2. So this is sampling. Random sampling is process of using chance to select individuals from a population to be included. They should have equally likely chance to be selected. So the sample size we'll refer to as a small n. The population size is capital N. We often use the words simple random sample to define that, to notate that. So we need to have a list of all the individuals in the population. That's called the frame. If we don't have that, we need to use different techniques, which we'll get into further along. So for an example, in example 1.10, suppose a study group consists of 5 students, Bob, Patricia, Mike, Jan, and Maria. 2 of the students must go to the board to demonstrate a homework problem. List all the possible samples of size 2. Without replacement, that means that whoever selected is removed from the next pick. It wouldn't be 2 of the same people. So for instance, I could have Bob and Patricia, could have Bob and Mike. I'm kind of going methodically here, Bob and Jan, so on and so forth. Then you get Patricia and Mike, Patricia, Jan, and you've already had Patricia, Bob, so we wouldn't count them again. So pause the video and just quick list out. You can use their initials, or you might need the first letter, like to differentiate Mike and Maria. Do MI for Mike and MA for Maria, and just pause and jot down the different possibilities that you would have. Okay, so hopefully you've listed yours out. Let's see how they match up. Here's the answer. So you can take a minute to check that over. And then we'll go on to the next thing. So in the book, we have instructions to use a random sample generator using the TI calculator, but we can actually do it with another one online. I'll show you. So you need to think about how many you want to have in the population, or how many you have in the population, and then what's your desired sample size. So here's the steps. I'll leave them there in the workbook. I didn't take them out. You can try that on your own if you want, but I want to show you a different one. So if we were looking at selecting a random sample, 3 out of a group of 30 students, I mean, we basically could list out the numbers 1 through 30, assign each person a number, and then just tear those little pieces of paper off, throw them in a hat, and pull out 3, and those would be the 3 people chosen. That would be one way to do it. Now we have technology, and we can use that. So I'm going to pull over this this website I found, calculator.net. I can post that, but you could just go into it, calculator.net, random number generator. And I will have this in your assignment, so you can click that link if you would like. So I had one from before when I was playing around with it. We need to do the comprehensive version here. So I'm going to put, I want, the lowest number I actually want is 1, and then 30. And then I want to generate 3 numbers. And I'm not going to allow duplication. I can put them in order just because it's easier, And then we want an integer for this one. We wouldn't want decimals because we're counting people. And then we just click generate. And so it would be person 10, 11, 12. That worked, right? That's legit. Kind of strange that would happen that way. 3, 18, 26 would be another option. I could increase, like to have, instead of, I'm pulling out, I want to get the grades or something from 12 of the students. I could just change the number and generate, and I would get a lot longer list. So that's what they're referring to as random number generator. And it's fairly simple to use, but when we go through more examples, if that comes up and you need to do that skill, let me know if you're struggling at all. So you can jot down what you got there. Answers will vary. Now we're going to look at the other sampling methods that are a little more complex. They're still really good, especially, well, some of them are and some of them aren't so good. So we'll talk about the reasons for that. So just take a minute to read through the definitions here. I'll read through them as well. Stratified sampling. It's when a population is divided into a number of subgroups or strata. Random samples are then taken from each subgroup, with the sample sizes proportional to the size of the subgroup in the population. Quota sampling is a variation of that, wherein samples are collected in each subgroup until the desired quota is met. Cluster sampling, it's when you divide into subgroups or clusters, and then a set are picked, kind of like states. You could, then pick only certain states, for instance. Systematic is every certain amount of or nth member of the population. I'm going to show you pictures of these in a minute. Convenient sampling is really, you're in your classroom and you're asking around those people that you know, Facebook samples, stuff like that. It's just whoever's convenient. Voluntary response is just having the data come from like, oh, those of you who want to tell me your grade, then, we'll count that for our data, we'll put those in. So you can see where the last two, which maybe even the systematic, but convenience and voluntary, just start thinking about like, what kind of problems might I have with some of these? But sometimes that's our only choice. I'm just going to show you a picture. So in this little diagram here, you can see simple random sample. It's kind of what we just did. You would take everybody on a number, throw them into a hat, or just randomly pick, out of the hat, or do it on a random number generator of some sort, and you would have your sample. Systematic sample, you can see that it's every third person, but often with that you may be wondering, why didn't I just start with the third person? You could do that, but a lot of times you have to start with, like, to make it really random, like pick a random start point. Stratified, you're going to have like this group of people. We don't really, it's just generic, like they're two different groups. We're not really saying what they are, but within that group, we're picking 2 out of the 6. And then the other group, we're going to randomly pick, just by a random number generator, simple random sample, 3 out of the group here. And that way we keep the same proportion. We're going to have 1/3 from each of those groups. Cluster sample, we're going to pick our, like say this was group 1, group 2, group 3, group 4, group 5, and then I'm just picking 2 of those groups. But I'm picking all of the people in some of the groups. Where stratified is different, I'm picking some of the people from all of the groups. And I could have more than just 2 groups in stratified as well. So hopefully that gives you an idea of what it looks like visually. You can look up the different kinds of sampling and see on the internet. I just did one here, and I thought this one was kind of funny to show. Convenient sampling. It's convenient. And we have the whole population of 100 students there that we're looking at, and 20 students are selected. So just like kind of taking the first couple of rows. It's useful in pilot studies, but it's really usually biased because, you know, maybe those students sit closer for a reason or whatever, or there could be a whole gamut of things similar to that. So just, you know, pointing that out. Now we have this example 1.2. In each case, indicate the sampling method. We have every fourth person in the class was selected. I'm going to make this a little smaller. You can see it in your workbook if you've printed that or have that pulled up, but you might not. So we want to make sure you can see it. So we have stratified, quota, cluster, systematic, convenience, and voluntary. So think about what every fourth person would be. B is a sample was selected to contain 25 men and 35 women. Viewers of a new TV show are asked to vote via the TV show's website. A website randomly selects 50 customers to send a satisfaction survey. And then E is to survey voters in a town. Polling company randomly selects 10 city blocks and interviews everyone who lives on those blocks. So you'll get questions like this in your MyOpen Math as well. So just to be familiar, you'll get lots of practice with that. So go ahead and pause the video and jot down what you think, and then I'll put the answers up. Okay, so hopefully you've gotten those down. Here's the answer reveal. Systematic is A, B is quota, C is voluntary, D random sample, E cluster. Okay, now we're going to look at steps for obtaining a systematic sample. So step 1, we want to approximate the population size n if possible. Determine what size we need, and a lot of times we want at least 30 in our sample. Step 3 is compute capital N over n and round down to the nearest integer. We'll call that value k. Then we're going to randomly select a number between 1 and k, and we'll call that p. The sample will consist of the following individuals. So we'll pick P, and then that's like our start one, and then P plus K, P plus 2K. So like the picture showed, it started on the second person and then it was every third. So let's see how we can do that with this set of data here. Create a 5-student sample from the class of 31 students using systematic sampling. Okay, so the first step here, just to go back a little, we want to approximate the population, and we're saying 31. Our sample size was given to us as 5. So now we need to take 31 and divide it by 5 for this example 1.13. So I'm going to just jot that maybe right here, and that's going to be my K. So you could do this along with me. K will equal 31 divided by 5. So when we calculate that out, this should be small. A lot of these are case sensitive. We're going to get 6.2. Then we're going to round down to 6. So we're going to do the value for every kth person, or I guess it's people. We're going to go every 6th one, but where do we start? We want to pick a number between 1 and 6. So we could pick whatever. I'm going to pick 2. So I'm going to say let P equal 2. So start with, I have Bayani, and then I'm going to count out 1, 2, 3, 4, 5, 6, or just simply go 2 plus 6 is the 8th person, would be Hubler. So if you get the idea, go ahead and jot those down. You can pause the video, and I'll pause as well and write up what I have. Okay, so if we get Bayani for starting, then we count on 6 to get the 8th person, or ID of 08, which would be Hubler, and then repeat, adding another, skipping up 6 more to get Messiers, and then Rays, and then last one would be Stracher. Okay, moving on to the end of section 1.2, we have variation in data, example 1.14. I just want to point out too, at any point, if you just want to do the problems and then check back against the video or make the video go faster, you kind of get the gist. As long as you're filling in the notes, you can write on paper too, so you don't want to print and use up a lot of paper. You can just type in a Word doc. It's really up to you, but just something that shows me that you engaged with the content in the lesson. So that being said, we'll move on to variation being present in any set of data. For example, 16-ounce cans of beverage may contain more or less than 16 ounces of liquid. In one study, 6 16-ounce cans were measured and produced the following amount in ounces of beverage. It's a little bigger for you. So we have 15.8, 16.1, 15.2, 14.8, 15.8, 15.9. So a lot of them are around, 15, but there's a couple that are different. So is that a big deal or not? We want to do quality control. We want to statistically figure out, what that is. And if it's significant. So measurements of the amount of beverage in a 16-ounce can vary because different people make the measurements. So we're going to run, tests to see what the variation is. And you'll learn techniques to really crunch the numbers and figure all this out. But right now we're just kind of talking about like what it means. You can kind of see that 16.1, oh yeah, that's a little bit higher. 14.8 is a little bit lower. They don't look too extreme. If I threw in like 18 over here, that would be, or like 5, you would see that would be a big difference, and you could eyeball it. But usually we need to use technology because, of course, we're going to have bigger data sets than that too. So the natural variation of samples is called sampling variability. It's usually unavoidable, but a lot of times it's not an issue because, as you can see, like here, they're probably fine. It's not a big deal. But if you're really having extremes, it is a big deal. And especially if it's something that's a safety issue too. Example 1.15, if we repeatedly take samples of 1,000 people from a population of likely voters from Washington state, some of these samples might have slightly higher percentage of Democrats or Republicans than the actual amount in the general population. Some samples might include more older people and some might include younger people. This is sampling variability. So not a lot to do with those, to answer, but just to go over those concepts. Critical evaluation. We need to evaluate the statistical studies we read about critically and analyze them before accepting the results of the studies. Not sure why these are 9s. I think they're supposed to be bullet points, but that's okay. Sampling bias is a sample that's not representative of the population. Voluntary response bias. When we have volunteers, you can kind of imagine how that would come up, but we'll talk more about those as the course goes on, and you'll see some examples and have reasons why we might have to do that if we're doing some of our work where we're just doing little activities and we're going to use I'm not going to force people to do things. You can't go out and just get data easily. So sometimes we might need to have volunteers, but that would be something in general you want to try to avoid if you can. Self-interest study. So somebody's funding it and they have an interest in it and the outcome. A lot of the, pharmaceutical companies, things like that. You got to see who's funding the study, what's going on. Response bias is where the responder gives inaccurate responses. Like maybe if I was in a class and I said, "Oh, what's your grade?" And you just had to tell me in front of everybody what you got on a test or something, and people might not want to share that. So perceived lack of anonymity, same kind of thing. Even if, that's more what I just said. For an example, response biases are just kind of lying anyway. Loaded questions is when you're kind of leading someone to say a certain thing. Non-response bias is a sampling bias where people refuse to participate in the study. And that's going to move us to displaying our data and using frequency tables and levels of measurement and going through that. So that will be in a different video in part 2 of your lesson. Have a great day.